We're now going to spend some time looking at subtracting integers. And if you were with us for the adding integers lesson, you'll know that we use the idea of heaps and wholes, and we're going to continue that idea for subtracting integers. If you're not sure about the heaps and wholes idea, you may want to go back and look at the adding integers video first, just to get an idea of what exactly that all means. But if you did see that already, you'll understand what's going on, and that's where we're going to start with subtracting integers, is using that idea of heaps and wholes. So this first problem that we're going to look at is -5 minus -3. So if I'm using that idea of heaps and wholes, this problem says start with -5 or start with 5 wholes. So we can look at it with our sand here, or we can look at it with our line, whichever way you like better. And we're going to subtract or take away -3 or take away 3 of those wholes. So I'm going to cross out, take away 3 of those wholes, and I'm left with 2 wholes, or -2. You can look at that same idea using it on the line here. I'm going to take away 3 of those wholes, and I'm left with 2 of those wholes, which is -2. So we're using that same concept of heaps and wholes again to look at subtracting integers. Another way that I could think about it, if I wanted to get rid of those 3 wholes, is by adding on a +3 or adding on 3 hills, because that would have also canceled it out. So it's just another way of thinking about subtracting integers, taking away those -3 or adding on 3 wholes, which will cancel each other out. Here's another problem that we can look at, 3 minus 4. So we're going to start with 3, +3, so that's like starting with 3 hills. So 1, 2, 3 hills, and now we're going to take away 4 hills. Well, that's kind of a problem right now because we only have 1, 2, 3 hills. So if we would think back to the idea of a hill and a hole canceling each other out, we can add on as many hills and holes as we want, and it's not like we're really changing the problem because they cancel each other out. So I want to add enough hills to our problem so that we'll be able to take 4 of them away. So if I have 3, and need to be able to take 4 of them away, I'm going to add on 1 more hill. But remember, if we're adding a hill, we also have to add a hole so they cancel each other out so it doesn't change the numbers in our problem. So now I have 4 hills and 1 hole, so that those 2 cancel each other out. And now I can take away those 4 hills, 1, 2, 3, 4, and we're left with 1 hole. This just gives us an idea over here of what it would look like, and this is not our actual answer, that's just what this looks like over here. We haven't actually solved the problem, which says take away 4 of those hills now. So 1, 2, 3, 4, and we can see in both cases that we're left with 1 hole, or -1. Just like on the last problem, we can also think about this problem as adding something on. So we could add on 3 hills over here, and that would have canceled all those out, and we would have been left with that 1 hole over there. So instead of taking away, it's like we're adding the opposite onto it. Taking a look at another problem here, this time we're going to start with -2, or we're going to start with 2 holes, which is what we have here, and we need to take away 1, which in this case is a +1, +1, because there's nothing in front of it, but we don't have any. So just like in the last problem, we need to add some hills so that we can actually solve the problem. But if we're going to add a hill, we also have to add a hole so they cancel each other out. And if we need to take away 1 hill, let's just add 1 hill. So here's what we did. We added 1 hill, but we also added a hole to cancel each other out. Now we can actually solve the problem and take away 1 hill. So here's my 1 hill. I'll take it away, and now we can see that we're left with 3 holes. Same thing over here. We can take away 1 hill and see that we're left with 3 holes. So -2 minus 1 equals -3. Just like in the last problem, we can also think about it the other way around, and we can add on some things. And this time we can add on a -1 and see that we also had -3. So all we did was add the opposite. You may be getting the idea of what our rule is for adding or subtracting integers. Let's try another one just to make sure we have this idea down before we look formally at the rule for subtracting integers. So here it says 3 minus negative 2. So we're going to start with 3 hills, and we need to take away 2 wholes. Just like in the last column, we can't take away 2 wholes because we don't have any, so we're going to have to add them on. But if we're going to add on wholes, we also have to add hills to cancel each other out. And so down here we can see that we added on those 2 hills, but also 2 wholes, so now we can solve our problem and take away 2 wholes. So I can take away those 2 wholes, and I can see that I'm left with 5 hills. Same idea over here. Take away those 2 wholes, we're left with 5 hills. Positive 5. Sorry about that. And just like the other problems, we can also think about adding on some other numbers. Here we can think about adding the opposite here. So adding on a 2, and we can see that we also end up with a positive 5. So it's another way of thinking about it. So now we can look at what is it that we're really doing. What is our rule for subtracting integers? And if you haven't figured it out yet, when we subtract integers, we always add the opposite. And what that means is that the first number we always leave alone. That's just the number that we're starting with. As you saw in all those columns with the sand, we started with that number. We didn't change anything. Then we can change the subtraction sign to an addition sign. So I'm just going to go right here and change that subtraction sign into an addition sign. And then we're going to change the second number to its opposite. This is the part that people usually forget about. We don't want to forget that. That just means that if this number is negative, we're going to change it into a positive number. If this number was positive, we're going to change it into a negative. And that just goes back to the idea of hills and wholes canceling each other out. We can add a negative number or we can subtract a positive number, and it's the same thing. We'll get the same answer. Now we can just use our rules for positives like we did yesterday, and we have negative 5 plus positive 7. And we know that if we have one positive number and one negative number, we're really going to subtract. So that'd be like 7 minus 5, which is 2. And take the sign of the larger number, or the larger number's absolute value. So what's bigger, 5 or 7? We know that 7's bigger is a positive number, so our answer is positive. We'll practice a couple more like that without our hills and wholes, just to give us the idea, make sure we got this idea down. So every single problem, if we have a subtraction problem and there's integers, we are going to add the opposite. Remember, that means that the first number stays the same. We'll change our subtraction sign to an addition sign and take the opposite of the second number. In this case, it's a positive 6, because remember, if there's no little negative sign there, the subtraction sign and the negative are not the same right now, then we're going to take the opposite. So this is a positive 6, so we're going to change it into a negative 6. Now we can use our rules for adding integers, and we know that if both of the numbers are negative, we're just going to add those numbers up and keep our answer as negative. So this would be negative 9. Moving on to this next one, we can see we're subtracting. We have integers, so we're going to add the opposite again. The first number stays the same. The minus sign becomes a plus sign, and we're going to take the opposite of the second number. In this case, we have a negative 13. The opposite of negative 13 is positive 13. So now using our rules for addition, because we're an addition problem, we know that if we have one negative and one positive, we're really going to be subtracting. So 13 minus 9 would give us 4. And then, what's bigger, the absolute value of 13 or the absolute value of 9? We know that 13 is bigger, it's a positive, so our answer is positive. One other one on here that I just want to take a quick look at is this one, 8 minus 12. It's a subtraction problem, but I don't see any negative numbers. But I know that if I have 8 and I try subtracting 12, we can't do that. We know we're going to end up with a negative number, so that's another time when we're going to add the opposite, because we know our answer is going to be negative. So 8 minus 12, I'm going to add the opposite. The first number stays the same. The minus sign is going to change into a plus sign. And I'm going to take the opposite of that second number. So it was positive 12. We're going to change it into a minus 12. Now our rules for addition say if we have one negative and one positive, we're really going to subtract. 12 minus 8 would be 4. And the larger number, larger absolute value in this case is 12, and that number is negative, so our answer is negative. Hopefully that gives you a general idea of subtracting integers. Just remember, when you're subtracting integers, always add the opposite. The first number stays the same. Change the minus sign to a plus sign, and take the opposite of the second number. If you do that every single time, you should get the right answer.